Now, a new interstellar guest, designated 3I, Atlas, races toward the inner solar system. However, what has truly unsettled the scientific community goes beyond its speed and trajectory. It's the discoveries made by the James Webb Space Telescope in its wake. Unusual gas emissions. Absorption lines defying explanation. And hidden within the data, a structured signal, a deliberate whisper from the abyss that left leading astronomers staring at their screens in stunned silence. Is it a natural event? A cosmic mishap? Or something intentionally left for us to find? From its initial detection, 3I, Atlas was already breaking conventional rules. Speeding through space at over 60 kilometers per second, outpacing any known asteroid, comet, or natural body, it slipped inside Jupiter's orbit, heading toward the Sun with alarming accuracy. But speed alone wasn't its defining trait. Its trajectory was astonishingly precise, gliding along the ecliptic plane as if it had been programmed to navigate with checkpoints. In contrast to other interstellar objects that arrive at haphazard angles, 3I, Atlas appeared to possess a flight plan. It would pass precariously close to Mars, offering an exceptional opportunity for observation, yet it would never approach Earth. During its closest flyby, our planet would be shielded by the distant Sun, as if by some design. That's when the unease escalated. Astronomers tracked its path backward to its origin, which aligned with the same part of Sagittarius that produced the WOW signal decades prior. A mysterious burst of radio energy that remains one of the great SETI enigmas. Now, another object from that same region was on its way, but this time, it wasn't silent. As 3I, Atlas approached the inner solar system, the world's leading instruments focused on it. The Very Large Telescope in Chile, the James Webb Space Telescope, and even radio arrays typically used for pulsar research turned their attention to it. What they discovered didn't conform to any natural behavior models. When sunlight hits a comet, ices sublimate, metals evaporate, and gases are released in predictable patterns, iron and nickel together, as they form in stars. Yet this time, Webb identified something unprecedented: nickel gas without iron. Such a discrepancy hinted at selection rather than chance, suggesting something was intentionally releasing one element while concealing the other. Strangely, cyanide, a substance typical in comets, spiked far too quickly for its distance from the Sun. This wasn't the gradual sublimation of ice, it resembled a sudden and explosive discharge, akin to engineered materials under pressure, not a natural rock. This isn't the first time we've encountered something like this. Back in 2017, the first confirmed interstellar object, Oumuamua, entered our solar system. It accelerated without explanation, lacking gas jets or a tail, exhibiting the silent propulsion of a spacecraft adjusting its course. Many in the scientific community moved on, but Avi Loeb didn't. He cautioned that we might have overlooked evidence of something engineered. Now, with 3I, Atlas, it feels strikingly similar, but even more alarming. Unlike Oumuamua, which vanished before we could react, 3I, Atlas remains near, persistently shedding strange gases and following a path eerily reminiscent of our own probe gravity assists. If Oumuamua was the initial warning, is 3I, Atlas a follow-up, a subsequent contact, or something else entirely? Then came the signal. Initially brushed off as mere interference, a faint pulse buried within spectral noise. But the James Webb continued its observations, and the pulse recurred. A mathematically structured rhythm echoing at intervals too precise to be random emerged. When compared to historical signals, fast radio bursts, pulsar rhythms, even the WOW signal, the similarities were haunting. Not only did it share the same frequency band as the WOW signal, but it also originated from the same area of space. This time, however, the signal wasn't distant, it traveled alongside the object, emitting not only light and gas but also seemingly communicating or transmitting. Whether by design or coincidence, it became clear that we were no longer merely observing a rocky passerby from the stars. We were intercepting a transmission. To grasp the anxiety stemming from this discovery, consider it through the dark forest hypothesis. This idea posits that the universe teems with life, yet none dares to speak, as silence equates to survival. Every civilization hides, fearful of revealing its location, worried about annihilation by something stronger. Viewed through this perspective, 3i, Atlas transforms from a mere visitor into a scout. Disguised as a comet, it's programmed to steer clear of Earth, emitting just the faintest signals while diligently measuring and mapping our solar system. It approaches but never draws too close, avoiding detection, fully aware that we are observing. Perhaps it was never meant to be seen. Or maybe this was a test, to ascertain if we're ready not for contact but for revelation. Because in a universe of silence, when someone finally speaks, everything changes. When conventional, infrared imaging played an essential role in this discovery. Webb successfully detected faint material jets emanating from the object, jets that standard telescopes would have failed to identify. Unlike the smooth, predictable tails of comets formed within our solar system, Atlas exhibited irregular, jagged bursts that pushed it in unusual directions. Rather than a gentle arc driven by solar heat, its acceleration appeared in erratic thrusts, sometimes forceful, at times pausing, and even intermittently reversing in intensity. The object resembled something vibrant with an internal pulse rather than a mere comet drifting under solar influence. This prompted researchers to speculate about the processes occurring within Atlas. One intriguing possibility is that crystalline formations inside the object may trap volatile gases until pressure accumulates, leading to explosive releases. Yet, there was more complexity to consider. Some acceleration events observed by Webb indicated no corresponding evidence of gas emissions. In essence, the object occasionally altered its trajectory without a detectable chemical trace. Most astronomers favored natural explanations, but the lack of noticeable outgassing during these changes intrigued many. It raised the question, could there be mechanisms in play that defy our current understanding, or forces beyond sublimation affecting its movement? Webb's observations compelled scientists to address these anomalies instead of overlooking them, cautiously leaving room for interpretations that border on the extraordinary. Atlas also serves as a portal into galactic diversity. Every interstellar object encapsulates the history of its originating star system. The unique organic materials and exotic ices found here provide insights into a chemical environment vastly different from our own. The acceleration bursts suggest a fragmented structure formed in a chaotic protoplanetary disk. Thus, the object acts as both a messenger and a relic, echoing the formation stories of a distant part of the galaxy. Moreover, these findings raise larger inquiries. The persistence of volatile-rich objects like Atlas opens up discussions about panspermia, the concept that comets and interstellar entities may disperse life's building blocks across star systems. Webb's observations revealed that Atlas released molecules in sudden, forceful bursts rather than a continuous flow. This suggests the potential for preserving complex organic materials for billions of years in space's frigid vacuum, only releasing them when warmed by a new star. Each acceleration event evolves from a mere physical quirk into a delivery mechanism for chemistry that could, under the right circumstances, nurture life elsewhere. Practical implications arise from this as well. If interstellar comets exhibit unpredictable acceleration, it complicates efforts to model their orbits or establish mission plans for interception. Traditional models operate under the assumption of smooth, predictable forces. However, Webb's findings revealed behavior that resembles a natural thruster firing erratically. Future spacecraft will need adaptable trajectories, ready to alter course if an object unexpectedly strays from its predicted path. In this manner, Atlas has already served as a proving ground for planetary defense and mission design. This revelation underscores the essential role of infrared astronomy. Past interstellar visitors, like Oumuamua, perplexed scientists because visible light telescopes could not determine if gas jets caused its peculiar acceleration. Webb's capability to detect thermal emissions eliminated that uncertainty, offering concrete evidence of gas release linked to its motion. This sets a new benchmark for studying future interstellar arrivals. Perhaps the most enchanting aspect of this discovery lies in the dynamic motion revealed by Webb. Atlas did not resemble a static body gliding serenely through space. Instead, it appeared restless, flickering, shedding material, and pulsating in bursts that made its trajectory tremble like a heartbeat across the cosmos. The visitor felt less like an inanimate rock and more like a character with distinct behaviors and peculiarities. Through the lens of Webb, Atlas transformed from merely a data point into a narrative unfolding, providing a glimpse into the enigmatic mechanics of worlds that formed around alien stars. Thus, with each photon Webb captured, it offered more than mere chemistry and physics. It delivered a movement narrative, a chronicle of a stranger traversing our cosmic vicinity. While Atlas is just the third interstellar object documented, it has already broadened our expectations for such encounters. It challenges our models, refines our scientific understanding, and reminds us that the universe still holds untold wonders waiting to be uncovered when we examine it closely.